Hello folks, today I'm talking about CFN Lambda, a custom Lambda-backed resource handler helper. It lets you write custom resources into CloudFormation. The use case that I wanted to show off today was the ability to add Amazon Lex bots to your custom resource set and therefore be able to build bots via CloudFormation. So it's actually not supported right now in CloudFormation. What we're trying to do is create a bot in here along with some intents and some slot types, and we want to be able to do that declaratively. I've set most everything up. The CFN Lambda package you can find on Node or GitHub, on NPM or GitHub. There's a whole bunch of documentation for how to use it, but basically you can quickly create custom resources like for Amazon Lex slot types, intents, and bots, which is what I just did today. So let me show you the source code for what one of these looks like. You set up, this is for the Lex slot type. You import your AWS SDK, the CFN Lambda package, and then create the service object for the service that you're trying to polyfill in this case. So you can actually create this SDK alias object, and you just pass in the API that you're using, the method that you want to alias to allow upsertion or creation in this case, and give it the property that you want to use as the physical ID for the CloudFormation resource. It's basically, if this property changes, then the resource will require replacement. Pass it an array of the properties that you'd like to pull out that are accessible in Cloud. These will be exposed as accessible in CloudFormation as get attributes. So for the update function, slots require that you pass in the checksum, so there's a little bit of logic here around getting the latest checksum, but very simple code. If there's no need to alter the checksum or anything, if the name has been altered, we don't need to worry about the checksum, so just go and run that upsert, blah, blah, blah. So there's documentation for all of this in the CFN Lambda package over here, but deletion is also very simple. You just give it the keys that you want to pass to the deletion call. This SDK method only requires the delete. And we pass the error codes that we want to ignore during CloudFormation deletion. 404 and 409 are the two different ones that the system could throw. 404 if it never existed, and 409 if it's already been deleted. So we don't really care if it throws these error codes when we're trying to do deletion. No update function is if you have an explicit dependency mapped in CloudFormation and it gets past an update call. CFN Lambda will detect that there needs to be no update made, and no update will run. This is so it's specifically so you can pass out attributes and the correct physical resource IDs on update. So we just export our handler as a CFN Lambda handler that has its create. Create is just going to directly use the upsert. Update requires a slightly extra logic around the checksum. Delete is as defined, and no update is fine. We have a little helper down here. This is just to grab the checksum off of an existing slot type. The three implementations for intent and bot are actually pretty much identical. The only difference is that there's also some helpers in these methods for coercing numeric properties. Since in a CloudFormation custom resource, CloudFormation actually passes in all properties as string. So this basically makes CFN Lambda go in and turn these into nums when you pass them as force nums. And there's a similar property called force bools that we use in the Lex bot. But it's pretty simple code. This is literally all I had to do to implement custom CloudFormation resources that enabled me to run Lex on CloudFormation, even though it's not supported. So in addition to making the resources and having this deployment tool where all you have to run is npm run deploy after you add, after you clone this repository. You could do npm run clone this repo and run npm deploy if you wanted, but these launch pages are also generated magically when you create anything with CFN Lambda. So when I launched, I specified that it would only be available in the US East version. It creates all my attributions, launches an HTML page that allows me to share my open source custom resource quickly. Again, this page is generated by the tool for you. You don't have to do any extra work. You click on the magic launch link, and then it actually pre-fills all the parameters that you need to use for your account. You accept that it's going to use IAM resources, and hit create. And that's it. So this stack will continue creating for about a minute or so as it creates the Lambda here. While I'm doing that, I'm actually going to go click on the magic launch links for the intent and the bot as well, so I can get full support for Lex. I'm using version 1.0.3 right now, so if anybody wants to go try them out, it's Andrew Templeton is the maintainer, and it's CFN Lex and then the name. So it's slot-type, intent, bot for those three. So I'm going to do the same thing here for intent, and the same thing here for bot, where I'll open up the launcher page, click on launch, check yes, create. So over in our CloudFormation panel, we should see, all right, that the Lex slot type 103 is already created. Those will finish running in just a second here. The installation is quite quick. So just wait until these installers are done building the stacks. What this is doing is it's installing Lambda in your Amazon account for this region that will fulfill the requests whenever we create a custom resource request. So in real time, we already saw that all three of them installed. The bot repository has an example template that uses all three of these resource types. It passes in parameters that allow you to configure and see how it works when updates and updates requiring replacement, updates not requiring replacement. There's default values for all of them, so you don't really have to set these. But the important part is, look at what we actually can do here. The CloudFormation template that you installed for each of these resources actually exports the service token as an importable value in every CloudFormation template in the region. So now you just specify, you pass the normal parameters that you would pass to a put slot type call. If you go and look in the SDK documentation, which is for slots in this case, here it's defined the different things that you need to do, but it's pretty straightforward if you've ever used the console here. You need to give the slot a name, you give it a description, and then you give it the values that it could be. So I'm going to go with red and white sauce. This would be marinara, and I don't know what white pizza sauce is, but whatever. I guess garlic. Then I've got one for the crust of the pizza that I want to order with my bot, and have a couple different types of pizza. I only did veggie and cheese, which you could imagine doing, pepperoni, sausage, a bunch of different things. So I've defined a bunch of these slots. All I had to do was set the service token as an import value. It's the name of the repository, hyphen the version with hyphens in it, and then the service token. And that actually just, all it does is it goes and imports the stacks that we've already run. It imports a Lambda in those stacks and references them to fulfill these requests. Now for an intent, it's significantly more complicated. I just say that it depends on the slots, since each intent requires different slots that you need to use. Standard stuff if you've ever done Alexa development or worked in the Lex console with filling out any of the HTML, in HTML, what the console looks like when you go over here. And if you were to go create a new intent, you get many of the same. Possible inputs to this. So just go read the service documentation for intents, and you can see what this JSON object format should be. Of course, if you're writing templates in YAML, it would be in YAML. We got some confirmation prompts that it can run with my slots that I've now defined. Sample utterances. Constraints for if they're required or not, the name of the slot type, and what slot type version, and different reprompts for the slot in this intent. Veggie or cheese, kind of typo there, but veggie or cheese pizza. Then finally, down here we've got the bot. The bot needs to depend on that intent that we just created, which I call order pizza. It's again a custom Lex bot, and all we got to do is reference the service token that was installed. If we go down, we can configure the bot name and the parameters. There are different abort statements, whether or not children may be able to use this. In this case, I just set it to true because sometimes kids want to order pizza. Clarification prompts for any kind of issues with if it doesn't understand things you're saying when it's reprompting for different slot values. The description, you can set the description, the parameters to see what a non-destructive update does, non-replacement update is, how long the session should be maintained, the intents that should be installed on the bot. This guy speaks English, and this process behavior is set to build to make the bot build as soon as it's created. And all I'm exporting, just for sake of illustrating that the bot is actually created, is the version, which will be latest in this case since I've not created a version manually, and the checksum of the bot so that I can use it for later updates. Again, with the bots, the intents and the slots, those checksums are automatically recomputed every time you update the resource because of the way that I implemented things. But I'm going to actually launch this template so you can see what it looks like. So I'm going to create a stack. I click create a template, upload a template to S3. So if you've already cloned the repository, then you should have cfn lex bot. You just pull the example template, hit next, and I'm going to call this bot demo. So that's the name of the stack. We can edit the bot name and order pizza. Make sure that you don't select a bot name or an intent that already exists because the stack creation will fail and it will automatically roll itself back. If you've never worked with CloudFormation custom resources before, while you're creating a stack, it looks very similar to normal resources. So if we start refreshing, we should see resource listings start to pop up and physical IDs finish as the creation finishes. The physical ID in this case will the slots, intents, and bots are just the name since they need to be unique anyway, so they're a good candidate for physical ID. So just like you're used to seeing with normal CloudFormation, we get all of these event reporting back and that kind of thing. If there was ever an error, you would be able to see the error reason and everything as well. So I'm just going to keep refreshing, but the implementations that I use with the SDK alias tool inside of CFN Lambda makes these run super quickly. So that's actually it. I just built an entire bot in Amazon Lex in 45 seconds. So let's go over to the Lex console and check out the bot. So it may be building still. So Lex actually takes a second or so to build, and the larger your bot is, the longer it'll take. Just make sure that you only start trying to use it once it's ready. So I can go over to my order pizza bot. I can see that over in the bot editor that all of my settings appeared correctly. I was able to create that in 45 seconds instead of taking a really long time in the console. I can actually test the bot with the voice or by typing messages into it. So I can say, order me a pizza, veggie, please. And I want red sauce. I don't remember what parameters I put into that slot value, but you get the idea. I've got a bot created here, and it would return the parameters back to me if I got it to correctly invoke the steps. But it's my fault for creating a stupid bot in the example template, but you get the idea. You now have a super fast way to define the bots in CloudFormation by, instead of having to write any of your own automation, you can just create a single huge file with all of your invocations, or you can make a script that generates one of these CloudFormation files and uploads it. So now you can actually share your bots, right? You can make a single declarative file that allows you to share bots. Yeah, so go ahead and check it out. Real quickly again, CFN Lambda is the tool that I'm using to create custom resources like this. In particular, if you're interested in bot development and you want a simple way to create them, go and click on the maintainer's launch page on each of my repositories. Again, it's Andrew Templeton, and my handle on Twitter, if you have any questions, is A Templeton. So AYE Templeton. So it's CFN Lex slot type, go and do the install. CFN Lex intent, do the install. And CFN Lex bot, then go ahead and check out the example template. I hope you enjoyed it.